Have you ever wondered what would happen if a colossal burst of radiation from the sun hit Earth? This isn't just science fiction. It's a phenomenon known as solar flares. Solar flares are intense eruptions of radiation that originate from the sun's surface, particularly in its active regions, such as sunspots. Picture this. The sun, a massive, burning ball of gas, is constantly churning and bubbling. Within this fiery turmoil, magnetic energy is stored in the sun's atmosphere. Occasionally, this energy becomes too much to contain and is released in a spectacular display of power and light, a solar flare. These are not just light shows, though. They are packed with energetic particles and electromagnetic radiation that spans the entire spectrum, from X-rays to UV light. So these solar flares, while fascinating, carry a lot of energy that can have significant impacts when directed towards Earth. Solar flares are not just about light, they contain much more. At their core, solar flares are intense bursts of radiation that unfurl from the sun's surface, primarily emanating from its active regions, like sunspots. But what exactly is in a solar flare? Well, solar flares are a cocktail of energetic particles and electromagnetic radiation that spans the entire spectrum. They're like the sun's own fireworks display, belting out everything from X-rays and ultraviolet light to radio waves. Alongside this radiant spectacle, solar flares also eject a flurry of charged particles. These particles, ranging from electrons to heavy ions, are flung out into space at near light speeds. The combination of these energetic particles and the wide range of electromagnetic radiation makes solar flares a truly fascinating phenomenon. They're a testament to the immense energy and complex physics at play in our very own star. All these elements combined make solar flares a phenomenon worth studying. So what happens when these flares reach Earth? Well, when solar flares are directed our way, they interact with Earth's magnetosphere, the region around our planet dominated by its magnetic field. This interaction can potentially spark geomagnetic storms. Now, what's a geomagnetic storm, you ask? Picture it as a temporary disturbance of Earth's magnetic field, caused by a solar wind shock wave. But here's where things get interesting. These storms can disrupt our magnetic field, causing a variety of effects. Among them, we can find satellite malfunctions and interference with communication systems. It's a bit like the sun throwing a cosmic wrench into our digital lives. However, it's not all bad news. These geomagnetic storms, while disruptive, can also lead to one of the most breathtaking phenomena the Earth has to offer. While these storms can cause disruptions, they also lead to one of nature's most beautiful spectacles. But more on that in the next scene. Ever heard of the Northern Lights? They're a direct result of solar flares. These magnificent light shows, also known as auroras, are a testament to the intricate dance between the sun's fury and Earth's protective shield. But how does this celestial spectacle come to be? Here's the fascinating part. Solar flares spew out an eruption of charged particles, a sort of solar wind that journeys across space. When these particles reach Earth, they collide with our planet's magnetosphere, the protective magnetic field that envelops us. This interaction induces a geomagnetic storm, a disruption of our magnetic field. The charged particles from the sun, now energized, make their way along the magnetic field lines towards the poles. As they descend into the Earth's atmosphere, they collide with oxygen and nitrogen gases. This collision excites the gases, causing them to light up and create the breathtaking auroras we know as the Northern and Southern Lights. But it's not all beauty and light. Solar flares can also have serious impacts on our modern technology. Imagine a world without GPS, satellite communication, or even electricity. Solar flares have the potential to make that a reality. It's a chilling thought, isn't it? These energetic eruptions from the sun's surface can have far-reaching effects on our technology-dependent society. When solar flares are directed towards Earth, they can cause havoc on our satellites, disrupting GPS signals and satellite-based communications. This could mean losing your way in an unfamiliar city, or a crucial distress signal from a ship at sea failing to reach the Coast Guard. But it doesn't stop there. Solar flares can also induce currents in electrical power grids. This could lead to widespread power outages, plunging cities into darkness and bringing daily life as we know it to a standstill. It's the equivalent of a cosmic storm, with the sun as its epicenter and our technology at the mercy of its fury. Given these potential impacts, it's crucial that we keep a close eye on our sun. How can we prepare for something as unpredictable as a solar flare? This question has driven scientists to devise ways to anticipate these fiery eruptions, despite their elusive nature. The sun, a ceaseless cauldron of activity, is continuously monitored by a network of telescopes and satellites. These cosmic sentinels observe the sun's active regions, identifying areas where magnetic energy is building up, signaling a potential solar flare. In addition to monitoring, forecasting the impacts of these solar phenomena is another crucial aspect. Solar flares, when directed towards Earth, can trigger geomagnetic storms, which can disrupt our technology and power grids. Scientists use data from their space-based observations to predict the severity of these storms, allowing for preventative measures to be taken. Despite these advances, predicting solar flares remains a challenging endeavor. The sun's complex magnetic activity and the random nature of solar flares make them a subject of ongoing research. But there's still more to solar flares than meets the eye. Solar flares aren't just a threat, they're also an opportunity for scientific discovery. The more we learn about these energetic eruptions, the better we can understand our sun's behavior. This knowledge is crucial in improving space weather predictions, helping us foresee solar events and their potential impacts on Earth. But our quest for understanding doesn't stop at predictions. Scientists and engineers are also working tirelessly to design technology that can withstand the effects of solar flares. These efforts range from creating more resilient satellites to developing robust power grids that can shrug off the currents induced by solar activity. The future of solar flare research is a synergy of astrophysics, engineering, and meteorology. It's a field that's as dynamic as the phenomena it studies, constantly evolving as we continue to unravel the mysteries of our sun. So while solar flares may seem like distant, abstract events, they are very much a part of our lives here on Earth.